We are always asking which AI model is actually the king. Is it GPT-4o? Is it Claude 3.5 Sonnet? Or is it Gemini? Today, we aren't just reading charts. We are putting them into the arena side by side to see who actually handles complex logic and coding the best. We're starting with a stress test for their brains before we get to the coding. This is the impossible constraint. I'm asking them to write a short detective story, but look at the rules. Every single word must start with the letter C, except for proper names. And the twist ending must be magic. This is incredibly hard for an LLM because they predict tokens, not letters. They usually break immediately. Look at the output. Captain Calloway carefully considered concerning crimes. It's actually doing it. It's maintaining the constraint while trying to keep a coherent narrative. This proves that these models now have the reasoning capabilities to follow strict instruction sets, which is exactly what we need when we start asking them to write code. But text is just a warm-up. Now we are switching gears. We are going into Bolt.new. This is an AI-powered development environment where we can drag and drop these massive models into a coding workflow. I'm prompting it to build a web app from scratch. Build a dragon's hoard with gold coin piles and click to collect interactions. I want to see if it can handle game logic, state management, and visuals all at once. It breaks it down. It's creating the project structure, the HTML, the CSS for the animations, and the JavaScript for the game logic. Notice, I am not writing a single line of code. I am just the architect telling the contractor what to do. And boom, check this out. A fully rendered game in the browser. We have a dragon, we have scattered jewelry, and we have gold coins. When you click the items, they disappear, and the total value counter in the top right goes up. The logic is flawless, but let's push it. A static game is boring. I'm telling it, make the dragon grow as I collect gold. This requires the AI to understand the existing code it just wrote and modify the state to trigger a CSS transform based on the score. It updates instantly. Watch the dragon in the center. As I click the coins, bam, bam, bam. The dragon is physically getting larger on the screen. It gamified the experience in one prompt. This would take a human developer an hour to wire up. The AI did it in 20 seconds. Okay, next test. Let's try something artistic. I want to see if it can handle complex CSS animations. I'm asking for a time-lapse flower blooming animation with multiple stages, petal unfurling, stamen reveal, and color transitions. This is tough because blooming isn't a native command in code. The AI has to mathematically calculate how to move div elements to look like organic growth. Look at that. It created 5 distinct flower types. When we hit bloom again, look at the stems. They shoot up, the leaves pop out, and the petals unfurl. It even added a sunflower logic, where the center looks different from the rows. This is high-level front-end design generated by a machine that has never seen a real flower. Now, let's get serious. Let's build something that looks like a real product. I want a futuristic spaceport departure board. I'm asking for a glitchy sci-fi aesthetic, status messages, and gate assignments. This is gorgeous. Look at the Nova Prime spaceport header. It nailed the typography. It created a data table with flight IDs, destinations, and real-time statuses like boarding or on time. It even hallucinated the lore for us. Hyperspace lane closed due to asteroid storm. It didn't just build the UI, it built the atmosphere. The glowing green text, the grid layout, this is ready to be used in a movie or a game interface immediately. Final test, the SaaS test. Can it build a functional tool that businesses actually pay for? I want a t-shirt designer. I need a color picker, the ability to add text, upload graphics, and drag them around the shirt. This is complex because it involves index layering, absolute positioning, and handling user uploads in the browser memory. And here it is. On the right, we have a full control panel. I click purple, the shirt changes. I click red, it changes. It's masking the texture of the shirt perfectly, so it still looks like fabric, just dyed a different color. Let's add some customization. I type hello, click add, and there it is on the shirt. I can add graphics, like this fire emoji, and watch this. I can drag it. The drag and drop functionality is working seamlessly. We just built a print-on-demand prototype in less than 2 minutes. This effectively kills the barrier to entry for building software. So, what did we just learn? We learned that with tools like Bolt and these new AI models, you are no longer limited by your ability to write syntax. You are only limited by your imagination, but I know this moves fast. Keeping up with which model is best and how to prompt them for code is a full-time job. That is exactly what we do inside my school community, Mike's AI Forge. We don't just show you the flashy demos, we give you the source code. We teach you the exact prompts I used in this video so you can go build your own SaaS, your own games, or your own internal tools. If you want to stop watching and start building, click the link in the description. Join the Forge, and let's automate everything. Thanks for watching, and I'll see you in the next one.